This is the second example for the one sample sign test. Let's take a look at the question. A random sample of 20 children are asked whether they prefer own brand, which has been labelled X, or big name, which has been labelled Y, breakfast cereal. And then we have a list of preferences. Using a sign test at the 1% significance level, test the hypothesis that the children prefer big name breakfast cereal. Now, a big thing to notice on this is that there is no numerical information. This is qualitative data, and we can only perform a sign test on qualitative data. We cannot perform a Wilcoxon, so we need to make sure that even if it doesn't state sign test, that we know 100% we can only use a sign test for this. As with any hypothesis test, we need to follow our 6 steps. So the first one being state the hypotheses, then state whether it is one or two-tailed on the significance level, calculate the test statistic, find the critical region, and compare and conclude. So let's start with the hypotheses. Now, unlike most of these distribution-free tests, we cannot use eta for this question because eta refers to the population average and we don't have an average. We are simply looking at a preference of X and Y. So our hypothesis needs to reflect this. We still need to use our null and alternative hypothesis, so H0 and H1, but they're going to be a little bit different for this one. Our H0 is going to be looking at the preference of breakfast cereals. Now, we're being asked if children prefer big name, so the null hypothesis has got to be nothing different, nothing is special. So it's going to be that children show no preference to their breakfast cereal. So I'm not saying they prefer one or the other, I'm saying there's nothing to it. Then the H1 is going to use that information from the question to say that children show a preference for big name breakfast cereal. So very different hypotheses to what we're used to. Step 2 and 3 are still the same. Is it one or two-tailed, and what is the significance level? So the one or two-tailed is a little bit trickier for these questions. H1 is that children show a preference for big name breakfast cereal. So that means I care about one particular cereal more than the other, which means this is a one-tailed test. If this was a two-tailed test, it would say something along the lines of children show a preference for a breakfast cereal. But I am specifically looking at one breakfast cereal, so it's one-tailed. Unlike many of our examples, this one is a 1% significance level stated in the question. Remember, if nothing is stated, you would always use a 5% significance level. So let's have a look at how we calculate our test statistic if I don't have numerical values. So normally I would look at calculating the sign difference, but we can't do that for this one because I've got no differences to calculate. So I'm just going to assign the signs as to whether it is successful or failure for my H1. So success would be that a child does prefer big name, and just reading the question again, big name is denoted as Y. So for every child that has said they prefer breakfast cereal Y, the big name, I'm giving them a plus. And for those children that have said they prefer the own brand, I'm giving them a Y, and I put those on the screen. So now I can count those pluses and minuses, and I can see that I've got 27 children, no I haven't, I've got 17 children that preferred Y, the big name, and 3 that preferred X, the own brand. The test statistic for these are always dependent on the H1, and our H1 is looking for big name Y. So anything that's agreed with Y is going to be included in my test statistic, and we said if it agreed with Y it got a plus, so the plus signs are my test statistic, and that is 17. Then we look at calculating the critical region. So for the critical region I need to state how I'm using the binomial distribution. So my statement says if H0 is true, then the probability that a child prefers Y is equal to the probability that they prefer X, and that is 0.5. Because if H0 is true and they show no preference, the probability of them choosing either one is 50-50. And once I've got this symmetrical probability, I can use a binomial distribution. So my n for this is 20 because I've got 20 children in my study, and the probability is always for a sign test 0.5. So using either the tables or I'm going to use my calculator, I'm just going to get some probabilities. So because p is 0.5, I have a symmetrical probability. So x being less than or equal to 0 is equal to x being greater than or equal to 20. And that has a probability so small we're going to call it 0. The same with less than or equal to 1 or greater than or equal to 19. Then as we start to move up, we start to get some actual probabilities, and I'm just going to show you the first 6 on the screen. Obviously it keeps going all the way down to less than or equal to 20. And let's remember for this question that alpha was 1%, so 0.01, and it's one-tailed. So I'm looking for all the probabilities that are less than or equal to 0.01. So looking down the list, I can see that 0.01, 1%, comes somewhere in between 0.059 and 0.0206. So that 0.01 comes somewhere in between those probabilities, and all the probabilities that are less than 1% are less than or equal to 4, 3, 2, 1, 0, or greater than or equal to 16, 17, 18, 19 and 20. So my critical region for this question is x is greater than or equal to 16. So let's look at compare and conclude. So for this question, I'm going to draw myself a number line going from 0 to 20. And I'm going to mark on my critical value, which was 16. And just shading what will be the critical region or the reject zone. Then I'm going to put in my test statistic, which was 17 pluses, and as you can see that lies in the reject zone, and therefore we reject H0. So to conclude that in context, I'm just going to remind myself of the question. Use a sign test at the 1% significance level to test the hypothesis that children prefer big name breakfast cereals. So by rejecting H0, I am saying that no, there's not an equal preference, there's definitely some sort of preference, and therefore I'm agreeing with my H1, and I'm going to say that therefore there is significant evidence to suggest that children prefer big name breakfast cereal.